Hello, welcome to another video in our GoJS beginner video series. This video will explain how GoJS diagram models are used to store simple data that is later visualized by the diagram as nodes, links, and groups. Using GoJS requires programming in JavaScript and familiarity with HTML and CSS. This video does not require any explicit prerequisite knowledge of GoJS topics. That being said, you may benefit from previously viewing What's in a GoJS Application, which delivers a broad overview of all the main pieces of a GoJS app, and Building Parts with GoJS, Parts and Panels, which delivers an explanation of parts, panels, and graph objects, and how they interact with each other. You can build diagrams of nodes and links in GoJS programmatically by calling diagram.add. Take a look at this code and the resulting diagram it creates. This works, but it does not scale well when creating large diagrams with many complex parts. You may want a varying number of nodes and links, many of which are similar to each other. It would be nice to have some separation between part data and part appearance. One way to achieve this separation is to use a GoJS model for your diagram. The diagram model manages part data, while diagram templates manage part appearance and behavior. This video is focused on how part data is managed in the model, but our video Building Parts with GoJS Templates offers an in-depth discussion for defining part templates. A GoJS diagram model stores JSON data represented by nodes and links in its node data array and link data array, respectively. The data stored in the model are not GoJS node and link objects, but rather just JavaScript objects. These objects' data is later used by GoJS to construct actual GoJS node and link objects, whose appearance is defined according to their corresponding templates. Inside those templates might exist GoJS binding objects, which bind certain properties in model data to appearance or behavior of the graph objects in their part. Since part data persists in the model, this allows for that data to be saved, loaded, or updated later on. This functionality could not be achieved by adding parts ad hoc the way we saw before using diagram.add. Furthermore, it would be difficult and very inefficient to serialize nodes and links because they have many unimportant properties that would have to be saved, whereas model data can be as simple and sparse as your app requires. Setting a diagram model requires setting your diagram.model to a new instance of model. A model can be declared using go.graphObject.make, or it can be declared as a new go.model. If a model is declared using go.graphObject.make, one may specify many properties during its creation. If it is created with the new keyword, only the node data array and link data array may be passed as parameters. Diagram models can be either the default model class, the GraphLinks model class, or the tree model class. The default model only stores and manages node data in its node data array. It does not support link data, and thus does not support a link data array as the GraphLinks model does. When adding node data into a model's node data array, we're adding JavaScript objects. These objects can have whatever properties you need. Since this is JavaScript, you will even be able to add or remove properties dynamically. Node data does, however, expect two properties by default, key and category. Key acts as a unique identifier for each node, while category specifies which node template in the node template map to use when node appearance is determined later on. If neither of these are provided, key will be automatically generated to be a unique string value, and category will be set to the empty string. Since the category data property is left empty, and this sample provides a simple node template, which is the same as specifying a template for the empty string in the node template map, all nodes will use this node template. For more on templates, see our video Building Parts with GoJS Templates. Let's make an example. We set our diagrams model by setting its model property to go.graphObject.make with go.model as the first parameter. We'll set the model's node data array property inside its properties parameter object as an array and pass it two JavaScript objects representing node data. We'll keep node data simple. We'll specify the key data property and a custom data property called color. This color data property is bound to the fill property of the shape element in the node template. Understanding exactly how that works is outside the scope of this video. Take a look at what we have. It's a diagram with two simple nodes. The next kind of model we will look at, the GraphLinks model, is the most general kind. It supports link relationships using a separate link data object for each link. In addition to the category property that node data supports, the JavaScript objects for links support two additional predefined properties, to and from, which correspond with the keys of the nodes and model data this link should connect. Additionally, just as with node data, link data can support any number of properties you need and can be updated dynamically. GraphLink's models support identifying connection objects, known as ports, within a node. They also support groups. Both these topics are outside the scope of this video, but it's important to note that if you want to use these features in your diagram, you will need to make sure it uses a GraphLink's model. Let's modify our previous example to use a GraphLink's model. We'll demonstrate an alternate way to set your diagram's model now. Instead of using go.graphObject.make, you can set myDiagram.model to a new go.graphlinks model. Inside the constructor, you may pass two parameters. The first is the node data array, and the second is the link data array. We can have the same node data array as before, but now we'll set the link data array as well. We'll specify one object for link data, and specify the to and from properties for it. We'll specify them to be the values of the keys of the two nodes defined in our node data array. Now see what we have. It's the same diagram as before, but now there is a link connecting our two nodes. The last kind of model we will look at is the tree model. The tree model is a bit simpler than the GraphLinks model in that it only supports link relationships that form a tree-structured graph. There is no separate link data or link data array specified in the tree model. Instead, there is now a new supported property for node data objects called parent, which, if set, must be set to one of the key properties of the node data objects defined in the node data array for the tree model. By setting the parent property on a node data object, this will create a link from the node corresponding with the key specified by the parent property value to the node with this parent property. If you need additional application-specific properties for each link, you must put them on the child's node data object, because each link corresponds one-to-one with a child node. Let's modify our previous example to use a tree model. Change the model type to tree model. Remove the link data array and add two new node data objects to the node data array. Set the parent data property for the last three node data objects to the key property of the first node data object. Now, if we load the page, we see our diagram has four nodes, three of which have links pointing to them from the first node. Note that just because our data specifies a tree-type organization for our nodes and links, our diagram does not necessarily look like a tree. To achieve this, you might want to specify the diagram.layout to be a tree layout. However, this is beyond the scope of this video. You can read more about creating tree-like graphs in the intro pages on gojs.net. To add or remove nodes to or from a model programmatically, use the model.addNodeData and model.removeNodeData methods. Simply modifying the model.nodeData array will not work, as GoJS will not be notified about the change to the JavaScript array. To find a particular node data object with its unique key value, use model.findNodeData for key. Let's return to our last example and add a node data object programmatically to the model's node data array. First, create the node data object. In our case, it's a simple JavaScript object with just two data properties, key and color. Then, we add it to our model using the model.addNodeData function. This will add the data to the node data array and also notify the diagram that it needs to create a new node. Now, look at what we have. There is a new node in our diagram. To modify a property of a data object in the model, use the model.set method. This method takes three parameters. First, the data object to modify. Second, the data property of the data object to modify. And third, the value to set the data property to. This method must be used to modify a data property. Simply finding the data and changing some properties will not notify any bindings in the corresponding part template of the update to model data. Let's return to our example and update the color data property of our new node. First, we need the data object representing the new node in the model, so we'll call model.findNodeData for key and pass in Zeta. Then we'll call model.set, pass the data object as the first parameter, color as the second parameter, and our new color, red, as the third parameter. Now if we load the page, we see the model data has changed, as the new node now appears with a red shape. While there is no requirement to save or load models in any particular medium or format, since JSON is the most popular data interchange format for JavaScript, GoJS makes it easy to read and write models as text in JSON format. Just call model.toJSON to generate a string representing your model. Call the static function model.fromJSON to construct and initialize a model given a string produced by model.toJSON. Let's go back to our example and add two HTML buttons on the page, save and load. We'll create a save function and load function, and set the on clicks of the buttons to these functions respectively. Make sure these functions are outside the scope of our init function so they can be called at any time. We'll create a variable to hold the model's JSON file contents, called file. For the save function, we'll set file to the string created by model.toJSON. For load, we'll set our diagram's model to the result of model.fromJSON with our file variable as its argument. Now load the page and press the save button. Delete the Zeta node. Press the load button. The model is updated with the last saved contents of file, which included the Zeta node. Delete a few more nodes, click save, then click the load button. It loads the model corresponding with the diagram we had when we last clicked the save button. In this instance, when loading happens, nodes are laid out again. If we want to remember node position data, we'd store that in our node data array data objects and use a data binding to bind it to the node's location property in the node template. For more on data bindings, see our video, Building Parts with GoJS, Templates. That's it for this video. To read more about the diagram model, see our intro page, Using Models, on gojs.net. The next recommended video is Building Parts with GoJS, Templates, which goes into detail about how to use templates for your parts and gives example node, link, and group templates. Head over to gojs.net to see hundreds of samples, read more about GoJS features on the intro pages, or peruse the full API documentation. Sign up for an unlimited free trial, and you'll get 30 days of developer-to-developer support for free.